Okay, so okay. Okay, so I had some minor issues with my camera, I guess. For some reasons, so there is a software. That's this. So guys, once again, I would apologize for this stream. I almost did not, almost to do this again today. Had to do, and a lot of running around and stuff. All right. So yeah. So today basically we're going to be talking about what's it called? Types. So I'll just share my screen. We're talking about types in JavaScript, right? So I'm going to be talking about types in JavaScript. We're already 12 minutes in, and I was kind of late for this one. So basically, I know you guys can already see my screen. Still have some setups to make with my, um, you know, my environment and the way it's looking. But I think I'll just go like this. Yeah. Okay. So today we're going to be talking about types. Going to talk about types, casting, literals, inference, aliasing, and possibly conversions. So I might talk about conversions, or I might have a second part for this series where I'll then go ahead and probably talk about conversions. Hopefully, depending on how smooth today's stream goes, right? So I'm having a lot of issues with my having code environment and stuff. So some days are like this where it looks like what I'm doing again, right? Okay, it's kind of lagging. Okay. Keep expanding it. Okay, so this is okay. All right, so yeah, so today, like I said, we're going to be talking about types in Rust. We're going to talk about casting. We're going to talk about literals. We're going to talk about inference. We're going to talk about aliasing. If there is enough time, because tomorrow is Monday, and one has to get ready for Monday. There's enough time. I'll talk about conversions, and yeah, so we'll see how it goes from there. So yeah, we'll see how it goes from there. All right. So guys, once again, welcome back to my YouTube channel. This is part of the Rust example series I've been doing. Like I said before, we are going to dive into Rust types. These are like fundamental, yet very powerful concepts in the language, right? We're going to dive into those. I'm trying to adjust my mic here. All right. All right. So the first thing I'll do is I'll go ahead and I would create a new file for what we are going to do today. I'll create a new file and I'll call it types and conversions, right? So I'll say types conversion.rs. So so I'll copy that. So I'm just basically creating a file here. Command A. And so add it here. save, and in my main.rs, I will just import it here. So what's it called? Types conversion. So I import every single thing. So I need everything from that file, right? So from our last lecture, we talked about variable bindings. So I'll just comment that out. And yeah. So guys, please leave a comment for me. It does help, right? It does help. It helps a lot to keep the channel going. Helps other people to see what we have going on here, and so on and so forth. And it doesn't take anything to leave a comment, right? It doesn't, to be honest. And yeah, anything. So I think my caption is still showing. Okay, that's gone out. All right, so guys, if you look at the screen, you'd see my my YouTube username. You can follow me on YouTube. Drop a comment, follow the live. There's also a link to this video on my Twitter. You can go on my Twitter and you'll be able to see. Okay, you'll be able to see a link to the video and all that. All right. So yeah, so let's go on. So now I've just successfully created a new file and imported it into the main. So I'll comment out everything that has to do with variable bindings because I'm not going to be using it today. So I'll just put a comment here and call it types. Yeah, okay. So back in the types folder, so let's talk about types, right? So Rust, as we all know, is a statically typed language, which means the type for every variable is known at compile time. This helps us to catch. It helps to catch errors early enough and ensures that we're writing code that is, safe and efficient. Rust uses this to provide several. Rust provides several mechanisms to define or change types. And some of them which include casting between primitive types, and let me just write them out here. So I'll say casting between primitive types, right? Casting between primitive types. Next is specifying the type literal. So specifying the type literals. Next is using type inference. So everything we're going to be learning today, using type inference. And last but not the least, it's called aliasing. Aliasing or aliasing types, just aliasing, right? So this is how Rust helps us to catch errors and ensure that we're writing type safe codes, that are efficient, and all these are done at compile time. So now we'll look at casting, right? So we'll look at casting in Rust. We'll write a function. So I'll call this function, just write a simple function called types. So this is our function we are going to export. We're going to make public, save, and in my main function, I will just bring that guy here, calling types. So I'll be able to run my code and get some things in my terminal, right? So back to close this, and leave this. All right. So here we are going to, first of all, we are going to look at casting, right? So casting. And with casting, right, we can be able to convert a float. So a float is like a decimal, right, to an integer, and then to a character, right? And when I write the code, we'll notice how Rust forces us to be explicit with our intentions, which in turn helps us to prevent bugs on the long run, right? So first of all, I would create a decimal. So I'll say let's decimal be equal to, let's say, 55.8. And we can see that I'm using Rust Analyzer, so it infers it for me. It just shows me that this is a type of F64. Then I'll go ahead and do something called explicit conversion. So explicit conversion. And here I would say let an integer be equal to, so I will now say let an integer be equals to decimal as a U8. So U8 is an integer type. So we have the unsigned and signed integers in Rust. So we have the i's and the u's, right? So we have the I8, I16, I32, I think I64, and U size, right? And I size, sorry. And we have the unsigned, which is still the same U8, U16, U32, U64, and U size, right? So we're going to convert this decimal to an integer. So we'd say let's decimal, so we had already declared it there, as a U8. So you can automatically see that this guy we had here as an F64, right, which is a float, we've automatically used the as keyword, not as in ASS, just as in AS, right? And not AS as in, yeah, AS. So we are not saying the decimal as a U8, so we are automatically or explicitly converting a floating type of F64 to an integer type of U8. An integer type, like I just mentioned, so these are like an unsigned integer. I can actually convert it to, let's say, let me say I convert it to an I8, right? I can still do that and it still works, right? You can see that Rust Analyzer says is an I8, right? All right. So I'll take it back to U8, I'll save. And I can still do same thing for a character. So I can say let's character, right, be equals to our integer. So this time around, our integer as a char. So as a char, right? So save this guy, and we can see, right? So we are explicitly, converting. We've converted the decimal from, from 55. That is from being a decimal to being an integer type, an unsigned integer, and converted the integer to a character, right? So if we go ahead and print this, you'd see. So let's do a print statement. So the print line and casting. So say casting, and we'll just kind of try to describe what's happened here. So I'll use an arrow. I'll put another stuff here. So we moved from an integer from a decimal to an integer, and from a decimal to a character, right? So we've done that, and we'll go ahead and say, let's pass our decimal here. Decimal, character, and integer. Just make life easier. Big strength. Cut this guy. Decimal, integer, and character. Why is it not coming up? Okay. Unused variable. Who said this unused? It's used. Okay. So we have this, and we can go ahead and let's go ahead and run this code and see what happens. So I'll cargo run. And when I do that, so you can see, right, we have our respective numbers. So you can see we have the type of 55.8, which is decimal, and we have the type of 55, which is integer, and type of 7, which is a character. So later on, I'll explain what's happening here as we go on. So we'll talk about what is it called again? We'll talk about how Rust uses, I think it's bits or something like that to kind of. So we'll talk about that as we go on. Let me not get ahead of myself. Right, so we'll talk about that. I guess basically it's casting rules. Yeah, it's called casting rules. That Rust follows to determine, the size of a particular type, right? So basically, Rust follows C style rules for casting between integral type, right? But one key difference to note is the behavior of Rust, right? It's well defined, and then what I mean by this is, for example, if we cast an unsigned type like we just did, right? If we cast an unsigned type, Rust adds or subtracts, right, until the value fits. So I was trying to explain that before. So what Rust does is it adds or subtracts until that value um, fits, right? So I'm going to do something like this, and uh, let me use some line of code to demonstrate this. I'll say print line, and this print line will say, let's say 1000 as a U16, as U16 is so here I would say I would just do the actual stuff. I'll say 1000 as U16. I'll save this and run it again. Let's see what happens. Exactly. So this works, right? Because it fits, right? So we're going to do the same thing for a U38, sorry, a U8, and you'd see that it wouldn't fit, and it will give us a weird number, but I'll explain how we arrived at that number. So we'll do the same thing for a U8. So I'll change this to U8. Also change this to U8 and cargo FMT. Oh, sorry. Save this. Save this. Save this. All right. Save 1000 as a U8. Draw out of range. Yeah, it's already saying it's out of range, right? It's already saying it's out of range. But this is just Rust Analyzer getting ahead of itself. But I will explain why it is out of range, so we can, try to understand. And this is not something. This is something. This is like a very in-depth theoretical aspect of Rust and how these integers works, right? And all these things comes together to add to the performance of the language, right? So you wouldn't basically be using a value or an integer size that is lesser than the required number you need, or something that is way higher than the number you need, right? If it makes sense. But as I was saying, if I run cargo fmt, formats that code, and I do cargo run, so when I do cargo run, I get, so you can see that here there's an error message, and this error message says, hold on, guys, please. If you have any question, you can always drop it in the chats, and I'll answer, or you can just leave a comment, something. Anyways, let's continue. So you can see here that we have an error. It says literal out of range for U8, but it's not saying the same thing for U16. Says this, so the literal 1000 does not fit into the type of U8, whose range is ranging from 0 to 255, right? So now if I okay, so basically this wouldn't work, right? Because if we do 1000, if we subtract 256 from 1000 and multiply it by 3, we have 232, right? So it wouldn't really fit into the U8 size, because according to, as we can see, right, this already tells us it doesn't fit in this range. But one thing I can do is I can just deny overflowing. I can allow overflowing literals. So I can add this to the top. So it allows us to print what we have in the terminal, right? I'll do that here. Paste that here. Take this out. Save, and let's see what happens. Let's see. Hopefully this allows us to. Save that, and let me run again and see what happens. Cargo run. It's not working. Is it allow or deny? Should be allow. Allow. Save. All right. So okay. So that error has gone because I'm now allowing overflowing literals. So let me print so I can better explain what's happening here. All right. So you can see that here we have 1000 as U16 is 1000, right? While 1000 as U8 is 232. So this is what I was trying to explain. So how did we arrive at that value, right? Where we have the 232. So it's basically the size of this the size of an I8, which is ranging from 0 to 255, which is a total of 256. So if we minus 256 from 1000 and multiply it by 3, right? That would give us something somewhere around this 232, which is how they arrived at this number, right? So it doesn't fit. 1000 cannot fit. What would fit into an AU8 is 232 itself, right? Now let's go ahead and do something for like a negative integer. Say print line, and here I would say -1 as a U8 is okay. So here I'll just wrap it in a bracket and say one is the type of I8, one I8, and say as U8, and I'll run this again. So this will give us 256, a bit 1. Okay, let me see what happens when I say 1 as U8. Okay, 1 as U8 is still 1. Okay, so I did some suffix. So I added like the integer suffix to the back of this integer, which is 1, the ending, and explicitly converted it to a U8. And of course it should fit, right? Because -1, I guess the U8, right, ranges from I think -255 to -255 to 250 plus 255. I think so. I'm not really sure about that, right? So I will just have to let the compiler show me some errors at this point, so I'll be able to remember what's happening. So I'll comment out that allow overflowing and literal out of range. Comment this out. Save and see what happens. There is no error whatsoever. Let me just do this as just 1. Oh, let me say it's U8 as U8. That's what happens. Anyway, nothing happens. So basically what happens here is the I8 fits into the U8. That is the one I8, that is 1, the integer type of I8 fits into the U8. So that would work. So basically what I was trying to show here is how Rust handles overflows, right? One thing to take note of is I didn't really do a wonderful job at explaining it, but it is worthy to note that in Rust, overflows are handled in a very amazing way, and it's predictable and safe, right? I guess it's since Rust 1.4, I think 1.44 or so, that you know casting from floats to integers performs a saturating cast, meaning it clamps the value to the bounds of its target, just like we had, right? So that's basically what happened here. And so I'll just take out these guys. Oh, sorry about that. So that's what happened here, right? So when we had a decimal of 5.5, we got that value, right? And when we converted it to a U8, it was clamped, right? It was clamped to the bounds of the target type. So it's clamped it down to 55 and did away with 8. Then when we converted it to a character type, it clamped it down to 7. So that's why we have this stuff, right? So it's important to take note of that. So it's very important. Okay, guys, sorry about that. I had like a minor glitch. So I was saying something about literals, and I said literals is a way whereby we can specify type of a neutral, like a numeric literal, by adding a suffix to the end. We've been doing this even in our previous streams, where we add suffix to the back of our. Oh, I think there's a comment. Okay. All right. Thank you, Chidera, for that. Mhm. Thank you for dropping a comment. I really appreciate. Okay, so as I was saying, so literals are basically what we've been doing, right? We've even done it here, right? Where we just add a suffix to the back of an integer, right? So it's basically something like this. Let's say we want an integer type of want to declare an integer, right? We can just say something like, let's say 80, and we say is a type of I32. So here the 80 is the integer, while the I32 is the type, right? We've been doing this. So Rust has a way of, you can use this to, you know, to state the type, right? The integer type for that integer. Let's look at some examples. So let's say let's x equals to 1. So if I leave it as this, Rust will give it the default type of I32, right? So I can add a suffix at the end. I know that we all know that we don't have only one type of integer. So we have the signed and the unsigned type, right? So I think I should draw up a documentation for that. I think it's in the documentation. I think integer types in Rust. We'll get back to that. 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 Anyways, so we know we have several integer type. We have the I32s, we have the I16s, we have the I8, we have the I64, we have the I size, right? And same thing, we have the unsigned, where we have the U8s, U16s, and so on and so forth, right? So we have all these, and Rust, like by default, gives us an I32. So we can change it to like a U8. I can say I want this to be a U8 integer type, and it's automatically change it, right? So Rust is smart enough to know that the first value here, which is 1, which is the digit, not the digit, sorry, and the integer is the number, and the suffix is the type. So we can do this, right? I can also do another one. Let's say let y equals to 2, which would be a type of I8. And we can now say let z be equals to 2.0, which is going to be a type of F32, right? So we can add the literals, like we can add the type to the back of the literals, right? But if we in a situation whereby we don't do that, Rust would automatically pass the default type for these digits, right? These values. So an example of this is if we say let I be equals to 0, so Rust will automatically give it a type of I32. And if we say let f be equals to 3.2, Rust automatically give it a type of, no, that's not 3.2, that's 3.2, to give it a type of F64 automatically, right? So what we can do now is that we can go ahead to print the byte size, and we do that by using something from the standard library called the mem size, right? Mem size, the mem, and in the mem we can get the size of values, right? And we'll pass some weird symbol at the front with the name of the variable that we had defined, and we'll use that to get the size that each of these values takes in memory, right? So I'll give an example of this. I'll say let me add comments, find the mem size. So mem size is memory size, right? So just call it memory size. So we can add the print line, and then I would say, sorry about that, say size of x in bytes, so I'll just do can actually do it at the top or below. I can say here I'll just do std mem, okay, do this, and here I would say size of value, size of val, right? Okay, size of value. Okay, so here let me just add it to that line. Take it back to this place, and I'll just say std size of val, and in that size of val, I'll then add the an ampersand and x, right? So this should give us the size that x takes in memory. So I'll save this and run it. Let's see. Okay, comment out any guy that I'm not using. I'm no longer using this guy. Comment it out. So we have a clean terminal. So I would I'll go run, and you can see. So you can see that this takes 1 byte, right, in memory. But of course, it will not be the same thing for this and this, right? So let's go ahead and do that. So I'll just copy this and duplicate it. 1, 2, save cargo fmt. So cargo fmt helps me format, kind of like a linter. So it formats the code. So here I want size of y, and I want size of z. save this and I run it again. This time I should have exactly. So we have the size of I8 is still okay. So this is still a byte of 1. So I'll change this to a U8. Sorry, a U32. Let's look at what that will give us. U32. Save that. Run it again. So here you can see that 2, right, takes 2 with the size of U8, sorry, U32, takes 4 bytes in memory, right? Also, 2.0, which is, has a suffix type of F32, takes 4 bytes in memory. While 1, which has a suffix type of U8, takes 1 byte in memory, right? So basically, the standard mem size of value checks the size of each variable in bytes. So that's basically it. So you just take note of how Rust does inference here for us, right? So it does inference, because we had not added suffixes at the end of this, right? So now let's go over to type inference. Type inference. Okay. So Rust type inference. So the Rust type inference is very, very smart, right? It doesn't just look at the type of value during initialization. It also considers how the variable is used later in the code, right? So I'll write code to explain what this is. So let's say elements. What's happening today? Be equal to 5. So it's type of U8. So we'll just add that type suffix. Right, so it's type of U8. So let's now say let's create something like an array, something similar to an array. Let's say let's new vec be equals to vec new right. So now in this case, right, the type is unknown. You can even see it here, right? Rust analyzer is telling me the type is unknown. If I want to add this by myself, I would add a semicolon, write vec, angle brackets, and put an underscore. It's still the same thing, right? So I can double click this and you can see it, right? So you can do this. So wherever you see this in Rust, right, being inferred, you should just know that it can take any type. That it doesn't know what type it is, right, at the moment. So I'll just go ahead and let me take that out, right? Just know that because we had not set any type, it would be a type of unknown. If I click this, right, and I put a type of I32 here, this, not 1, 2, 3, I32, right? This vec would only be able to take I32s. You can even see it here, right? So we'll be able to take integers, right? If I put something like a character, to only be able to take characters. If I try to put something that is not a character here, to break, to throw an error. So I'll just undo this to unknown, and I will leave it like this, right? So now, the reason I'm doing this is because I want to illustrate how type inference works in Rust. So now, when I come here and I do vec.push, so vec.push, and I push elements into the vec automatically takes the type of the element. So you can automatically see that, my Rust analyzer is telling me to, type annotation needed for vec, right? So I have to pass the type of, U8 to this, right? So I'll click here and you can automatically see that, it now takes a type of U8. So if I go ahead and print this, print line, and I will just format it, just a simple format. Pass my vec. Still believe that if I take this out, save. That's what happens exactly. So I don't even have to put that, like write that explicitly. It would automatically know that what we've passed in here, because we passed the elements. If you take a look at line 38, we've passed that element, which is has a type of U8. We've pushed it into the vector, which is kind of like an array coming from a JavaScript background. And we've pushed it into that place, and it's this vector is now taking the type of U8 because of this value is a U8, right? So if I define something else, let's say let's character be equals to, let's just say A, right? So it's type of string slice, and I then, instead of pushing elements, I push character into that place. So char, you'd see it automatically takes the type of, it automatically takes the type of a string slice, right? So you can see here in ash, in gray, whatever color, is now the type of string slice. So whatever I push in here, it takes the type of it, right? It takes that type and, infers it into the vector. So I'll just undo that. Don't need it. I'll save and I'll just print. I'll run. And I should have, I should have my 5. So you can see it's kind of like an array, right, from JavaScript. The only difference is that it cannot take different types. It can only take like an integer or a float or a boolean or I think, or a float, right? So it cannot take a float and a boolean at the same time. So, like I said initially, the compiler inferred the V8 U8 for us here, because we pushed the elements, which is a type of U8, which we had explicitly inferred, or sorry, explicitly declared as a suffix at the end of this integer, right? So this kind of saves us from writing redundant code, and also gives us, like, makes our code type safe, right? Because we always know that the compiler will help us to do the inference, right? So these are just like simple concepts to take note of. So next we're going to talk about type aliasing. So we're gradually coming to the end. I'm talk about type aliasing. So say aliasing types. So this is kind of I say a nice to have, in my opinion. It's a nice to have in that this does not add any, it does, type aliasing doesn't add any extra layer of type safety, right? The only thing it does, in my opinion, I would say the only thing it does is it just adds an extra layer of making your code more readable and reduces boilerplate code. That's my own, I believe so, right? And I know a lot of people believe so. And it doesn't add any extra layer of type safety. It just reduces the boiler code in your project or in your code, right? So an example of this is anywhere you see something using type, just know that that is like a type alias, right? So we can say type. So we have the type keyword. Let's say nano sec, and we'd say is equals to what? Let's say nanosec. Anywhere we see nanosec, we know is a type of U64, right? So we'll create another one and say type of inch. We'll set it to a U64, and we'll have a type of capital letter U64. I'll set it to U64. U64. Exactly. So now we can go ahead and say let's nano sec. We'll just alias it to not this has to be capital letter. Okay? Yeah, it has to be capital letter nano sec. Exactly. So it should be upper camel case. Yeah. Nano sec, and this should be inch inch. Exactly. So this is type aliasing. So we would now say nanosec would be equals to like a nanosec colon nanosec in capital letter, right? And we'll say it's equals to 5 and just say as a U64. So we just did what's it called? Casting, right? Yep. So we just did explicit conversion, basically casting the type. So we also casted it here, right? We have that. So we are saying instead of writing U64 all the time, right? So we just have we just have to pass this instead of writing U64 everywhere. We just pass nanosec here, and let's do something similar for inches. I'll say let's inches equals to inch. This 2 as a U 64. So we're also using it here, so we can use it to do our casting, right? So we're using this guy to do our casting. So you can go ahead and print just to show that it works. Print line. So guys, forgive me, I am incredibly tired. I'm just trying to. Anyways, so I'll say nanosec plus inches. So it will be equal to units. So I'm just saying it's going to be equal to units, and here I will just pass my nanosec inches, and then nanosec again, plus inches. Save this and let's run the code. I'll go around. Yeah. So we have 5 nanosec plus 2, which will give us 7 units, right? Yeah. So guys, that's basically it. We've gone over a lot of things. So we started with casting with the ask keyword, right? Using the ask keyword to cast our types for our values or our variables. Then we talked about literals. I talked about literals, how we can add a suffix at the end of an integer type that we want it to have. Then went over to check memory size of each of those integers using the mem size of value from the standard library, the raw standard library. Then we went ahead to do some type inference, right? So we did some type inference where we defined a variable, added the type as a suffix to that integer, and then we created a vector and pushed that element into the vector, and we can see how that vector took the type, right? It inferred the type of this integer for the vector, meaning this vector can take only types, of U8, integer types of integers, not just integer type of U8, right? Yeah. Then went ahead to do type aliasing, which I just showed now. Yeah, so guys, I think that's basically it. I wouldn't be able to go over conversions and all the string conversion stuff, and this is because this stream is already too long. It's already over an hour. So I'll be doing a part 2 of this, where I will talk about conversions using the from and FromInto, TryFrom and TryInto traits, and then we'll also do like some string conversion using ToString and FromStr, right? The FromStr traits. So guys, if you enjoyed this video, don't forget to give me a like on YouTube and subscribe, hit the bell icon. Um, you know, so thank you so much for joining me on this one. And I would see you in the next one. Guys, please don't forget to drop a comment. It does really help. It helps the channel, helps more people to see the content. And thank you so much for joining me on this one. And I will see you in the next one. Bye. So I will still hang around. If you have any questions, you can always drop it in the chats. Yeah. So thank you guys for joining me on this one. And bye bye for now.